Welcome to Study Loop.
This problem references the previous exercise, 42b. If you haven't had a chance to look at 42 yet, take a moment, look at that problem, and then come back here. Okay, so in 42b, we proved that this is true, that the left-hand side is a subset of the right-hand side. Now, it is possible that this is a proper subset. In other words, this left-hand side is a subset of the right, but they are not equal to each other. So to show that, let me give you an example where it is a proper subset. And there are many examples here. This is just one. I'm going to let my set S, we're going to keep this simple, so I'm just going to give it two values, 0 and 1. And I'm going to also keep T simple. I'm going to say T is a set also of two numbers, 1 and 2. And here is my function. I'm going to say my output of my function is 1 if x is even, and 0 if x is odd. Okay, so if I have f of 0, f of 1, and f of 2, those are the three values I have in my two sets here. Okay, if it's even, it's 1. If it's odd, it's 0. Okay. So the possible values for my outputs for my elements in S are 0 and 1. And T also have possible outputs of 0 and 1. Okay, so let's take a look, though, at my subset here. On the left-hand side, I want to know the output of the intersection. Well, if I look at these two sets, the intersection only has a single point, 1. F of 1 is 0. So here, the left-hand side is going to be 0. Okay, on the right-hand side, I'm looking at my two output sets. The intersection of those, well, those are identical sets. So the output here has both 0 and 1. So 0 is a subset of the set 0, 1, but they are not equal. So this is indeed a proper subset. Okay, now for part B. I'm going to scroll down and I'm going to recopy that piece for us just so we can reference it. So let me recopy. I have f of s is a subset of f of s, f of t. Okay, what we want to show here, we proved this direction in exercise 42, that the left-hand side is a subset. Now, if f is 1 to 1, we want to show that these are equal sets. Okay, so if f is 1 to 1, these are equal sets. Now, the example I gave showing proper, this is not a 1-to-1 function. As you can see, I had two different inputs that gave me the same output. So it was not 1-to-1, it was a proper subset. But what if it is 1-to-1? So what we need to do is we need to be able to show that it goes the other way too. We need to show that the right-hand side is a subset of the left-hand side, given that f is 1 to 1. So in order to start that, we're going to let y be an element of that right-hand side. Y is an element of this intersection, which means y is an element of f of s, and y is an element of f of t. Okay, so what does that mean? Well, let's look at the first piece. If y is an element of f of s, then there exists some value, we'll call it x sub 1, that's in set S, so that f of x sub 1 is y, and x sub 1 is an element of S. We also know for the second one, we'll call this one x sub 2. There exists an x sub 2, where the output of that function is y, and x sub 2 is going to be an element of t. Well, if f of x sub 1 is y, and f of x sub 2 is y, and this is a 1-to-1 function, that means that x sub 1 has to equal x sub 2. So this x, we'll just call it x sub 1. So x sub 1 is an element of S, and x sub 2 is an element of S. So that means x sub 1 is an element. I miscopied here. Sorry about that. X sub 1 is an element of S, and X sub 1 is an element of T, since X sub 1 and X sub 2 are the same. And that's hard to read. Let's try and clean that up a bit. Okay, so X sub 1 is an element of the intersection. Therefore, Y is an element of F of S intersected with T. And that is the left-hand side. So that is what we are trying to prove. That shows that F of S intersected with F of T is a subset of F of S sub T. So this actually is equality as long as F is 1 to 1. Now, if F is not 1 to 1, this proof doesn't work. We needed it to be 1 to 1 to make that leap right there. But as long as it's 1 to 1, this is an equality.